Okay. Come on. Gravitational potential. Okay. So in this portion, we are basically discussing the gravitation in term of energies, right? So in term of energies, it is going to be okay. So first of all, if we talk about the gravitational potential, so gravitational potential is going to be the work done. Okay, it is the work done per unit mass in moving a mass from from infinity to a point. Okay, so this is the first concept. Okay, and this is a concept of the gravitational potential. If we talk about the formula, so the formula is we mainly refer the gravitational potential with phi. Okay, but for okay, but in different syllabus or in different boards in different books, they mainly refer this with V. Okay, so but we are going to refer it with phi. Okay, so gravitational potential is basically the work done, which is the gravitational potential energy per unit mass. Okay, so let's first talk about the concept of the U, which is the gravitational potential energy, and then we'll put the values in. Okay, so this is U, okay, which is gravitational, sorry, gravitational potential energy, okay, energy, and this is going to be the mass, okay, and that is the gravitational potential, okay. So the unit for this one is going to be joules per kg, okay, right, and it is a scalar quantity, okay, quantity, right, okay. Now so this is a concept of the gravitational potential, right? So if we talk about the gravitational field and then we'll gravitational potential energy and then we'll relate the two things. So okay, so let's see the gravitational. Okay, so gravitational potential energy. Okay, so in AS level, we used to write the definition of the gravitational potential energy as the energy is stored in an object due to positional change in the gravitational field. Okay, so in O levels we used to write wait. So in O levels or AS level we used to write little smaller. Okay, and if I want the color, okay, so we used to say it is um energy. Come on, energy. यार कलर सेलेक्ट करो तो ये मसला है energy store in an in a mass due to the positional change in the gravitational field. Okay, field. Okay. So this is the definition that we used to give when we were doing the O levels and AS levels, right? But for A2 levels, we have to, okay, infinity point. Okay, but for AS level, we are not allowed to use a similar definition. Okay, we rather say, for this definition, we use the formula of GPE, GPE as mgh, right? This is the formula that we use, right? And since G is not constant in this scenario, right? While M remains a constant and H varying, but G it is not constant, right? 9.81, because 9.81 is a gravity only on the surface of the Earth and not anywhere else. Okay, like if we move up and up, so the gravity value changes. Okay, so that's why we are not allowed to use this formula anymore, and the definition changes accordingly. Okay, so now we used to write the gravitational potential energy as, wait, come on. So now we used to write the gravitational potential energy as, so the energy, okay, or it is a work done, and then blue, it is a work done, um, in moving a mass from infinity infinity to the point in the field. Okay, to the point in the field. Okay, so this is the concept of the gravitational potential energy that we will going to be using in our A2 level. Okay, so okay, and both the definition are slightly different. Okay, the gravitational potential definition, or the gravitational potential one, was the work done per unit mass, and the definition is over here the definition is work done in moving a mass, not per unit mass. Okay, so and the formula that we're going to be using is GPE is equals to capital G MM and then R with a negative sign. Okay. Okay. Because if you ignore the negative sign, then the whole scenario changes, right? Because in the previous case, we relate the gravitational potential energy directly with directly with H, sorry, directly with H. But now we are relating it inversely with H. Okay. H over here is R. Okay. So to make the relation correct, okay, or workful, we just put the negative sign in. Okay. So the negative sign will change the scenario, right? Now, let me just, okay, let's try to put the gravitational potential energy into gravitational potential formula, and let's see what it going to give me. Okay. So phi is equals to GMM over R and whole divided by M with a negative sign. M and M goes off, and you will be left with minus Gm over R. Okay, so this is the formula for the gravitational potential, where R is going to be the distance from where R is going to be the distance from the center of the planet, okay, to the point of observation. Observation, right? So this is the concept of the gravitational potential energy, and yep. So now, if we try to find out the values of the gravitational potential energy with a negative sign, then it will be correct. Okay. So let's say I have a planet. Okay. Let me consider a planet. Wait. Okay. So let's say this is a planet, and the center is going to be, or the mass is going to be, or let's assume that as a Earth. Okay, and the mass is, let me just erase this thing.
So could you go back to the definition
Yes.
of R? No, I just want to see what R is.
Hmm. R is the distance from the center of the planet to the point of observation. Okay.
Okay.
I want this big. Okay. So let's say this is a planet. Okay. And the distance from the center of the planet to the point, okay, let's say we are here. Okay. And the other mass is right here. Wait, sorry. It is right here. Okay. So this is the other mass. Okay. And let's say that we have the separation, okay, and if we talk about the gravitational field and potential both as well, so it will going to be, okay, so the distance that I'm taking is, it should be, let's say, 6.0 exponent 6. Okay, let's say this is one distance and this is, let's say, point A. Okay, now if I go to point B, and point B is, let's say, right here. Okay. Okay, so okay, so this is, let's say, point B. Okay, and it is separated from the center by the distance of 8.0 exponent 6. Okay, so if you try to find out the gravitational potential and potential energy, okay, let me give you the mass of this object as 1 exponent 30 kgs. Okay, and let's say the mass of this object is, let's say, 200. Okay, so this mass is 200. So the small m is 200, right? Okay. Now, if you try to find out the value, so what will you do? So
Of
I
psi?
just want, yeah, I just want you to find the value of the gravitational potential first and then potential energy. Or yes, find the potential and potential energy both for A and B as well, right? Clear?
Okay.
Fine. Now let's try. Yes. So this distance is this much and this distance is this much. Okay, both are in meters.
So psi of both A and B?
Yes.
Okay, okay. M gets cancelled out, right? So it doesn't matter if you know M or not.
Yes. Yes. But for the energy, you should.
For the gravitational potential energy.
Yes. If you are finding the gravitational potential energy, then you have to use M. But for the potential, like for the phi, you won't, you don't.
Okay. And we're calculating gravitational potential.
Okay. How much?
Just 1 second.
The working should look
Uh,
like.
it
Hmm.
is minus 1.1 into 10 to the power 13.
For A.
Sorry,
For A. Okay. So, and you should do 6.67 exponent negative 11, right? Into 1 exponent 30, right? And 6 exponent 6. Okay. So you're saying how much you're saying?
minus 1.11 into 10 to the power 13.
Exponent 13. Okay. You have to do the similar thing for B, but just change the denominator value. How much?
Minus 8.34 into 10 to the power 12.
Okay, if I write 0.83 exponent 13 for the conversion, and that is joules per kg. Okay, and joules per kg as well. Okay, so you can see that which value in your mind would be greater, the first one or the second one, considering the negative sign as well. Yes, which value do you think is greater value, the first one
Uh,
or the second one?
the second.
The second one is the greater value, right? Because it is close to zero, and anything close to zero with a negative sign going to be considered to be a greater value, right? Now, if you consider the negative sign and the values, so you can see that this relation is actually correct as a previous one, where but the relationship between the G and the gravitational potential energy both are opposite, but still it is correct because we know that at point B the gravitational potential energy should be greater, right? At point B generally it should be greater because of the greater distance if you use mgh, right? If you use mgh for that. But and if you're using the same formula, if you use this formula, then you'll end up getting the same answer. Like you'll get the greater answer for B than for A, right? And we are getting the greater answer for gravitational potential. By the way, we calculate the gravitational potential if you multiply multiply the mass with the both values, so you'll still getting the same, like it's still getting the B as a greater one and A as a smaller one, right?
Is that because bringing a mass from further distance cause it to be smaller, as in like less negative, so that means bigger.
Yes, yes, same thing. So basically, they sometimes ask you why the gravitational potential is negative, right? So why the gravitational potential, or sometimes potential energy, but mainly they ask for the potential, why the potential is negative, negative for all of its value. Okay, so we say that the first thing is the gravitational potential is maximum at infinite distance. Okay, this is the first thing. Say, and then second thing is infinity is considered as zero, as zero, right? And then moving toward the planet, um, moving toward the planet causes the loss in gravitational gravitational potential energy. Okay, so negative. Okay, now let's try to understand the concept. Okay, so let's imagine that I have this thing, copy and paste. Okay, I have this planet right here. Okay, and let's say as I move away from the center, the gravitational potential energy increases, right? And it will going to be maximum at maximum distance. Okay, so let's say this is the maximum point where you can feel the gravitational field. Okay, after this point, there isn't any gravitational field. Okay, this is a maximum point, right? So at this point, if and let's say the distance is infinity, okay, or infinite distance. We don't know. This is the maximum distance, okay, that we can get, okay, where the gravity is like where the least gravity, or where the gravitational effect would be like it is the last point where the gravitational field effect there, okay, and after that point there isn't any gravitational field, okay, for this planet, right? So at this point, GPE is going to be maximum. Sorry, it's going to be maximum, right? But because of the distance is maximum, right? But since we don't know the value for the maximum, so we considered this point, the gravitational potential energy at this point, or the gravitational potential at this point, as zero. Okay, this is what we consider. Okay, so we say let GBE is zero at D is infinity, right? Now, if you go outside, it remains zero, right? Because there isn't any gravitational field outside, right? But if you come inside, okay, so you are basically moving from infinity closer to the field, okay, and gravitational field is attractive force or attractive, okay, so it will help you lose the energy stored in the body, okay. So you can add one more point, and gravity is attractive, sorry, attractive in nature, okay. So moving toward the gravitational field, moving toward the planet causes the lose in the gravitational potential energy. So negative gravitational potential or potential energy both going to be negative, right? Is that clear? Yes.
Yeah.
Okay. So this is the concept, and these are the 3 points that you should remember for the explanation. Okay.
What's the fourth point?
Not the fourth point, but just I added right here. Okay. The gravity, the gravity is attractive in nature. Okay. So if the force is attractive and you're moving toward the force, so basically you don't have to do any work done, okay? Because you're moving in the direction of force, right? If somebody pulling you, then it will be easy for you to move through it. But if somebody pulling you and you don't want to go towards it, or towards him, then you have to do the work done to move against the pulling force, right? So this is the concept, right? Now, that is done. Okay. Okay, let's just keep this class right here. Okay. We have one more concept remaining. Okay. And then we'll do that concept in tomorrow's class, and then we'll be done with the chapter. Okay. And on Saturday we'll do the questions. Okay.
Okay, could you go down to the last
Mm-hmm.
diagram?